Picture this. A man climbs into a two-seat aircraft parked in an open field outside a Chinese city. There's no yoke, no throttle, no instrument panel bristling with switches. He taps a destination on a touchscreen the way you'd order coffee, and the aircraft lifts itself into the sky and flies there. No pilot's license, no flight training, no human hands on any control surface for the entire trip. That is not concept art. That is not a rendering some studio built to go viral. That flight happened, on camera, in the real world, and it is one of 8 flying vehicles we're about to walk through today that are already built, already tested, and in several cases already certified to carry paying passengers. Then, once we've covered all 8, we're going somewhere you won't expect. Down to the ground, to an engine that just got independently verified at 106 miles per gallon, a number so far outside normal combustion physics that it briefly stopped engineers on 3 continents from saying anything at all. 2 revolutions happening at the exact same time, one in the sky and one under the hood, and by the end of this, you'll understand why the next decade of getting from point A to point B is going to look almost nothing like the last 50 years. If breakdowns like this are your thing, hit the like button right now. We're pushing toward 50,000 subscribers, and every single one of you moves that number. Let's start counting down, because vehicle number 8 is the kind of idea that sounds like a joke until you actually watch it work. Number 8, the Xpeng Aero HT land aircraft carrier, the truck that gives birth to a plane. Xpeng Aero HT, a Chinese company already building both electric cars and flying vehicles, looked at the flying car problem and refused to solve it the way everyone else was trying to. Most competitors were attempting to build one machine that drives well and flies well simultaneously, and ending up with a vehicle that does neither convincingly. Xpeng asked a sharper question instead. What if the car and the aircraft were never meant to be the same object at all? Their answer is a 6-wheeled electric truck, rugged and oversized, that hides a fully electric 2-seat aircraft folded into its cargo bay like a mechanical secret. Drive to an open field, press one button, and the aircraft unfolds itself out of the truck bed, completes its own pre-flight sequence, and within minutes, you're airborne. Here's the detail that actually makes this commercially serious. Because the aircraft runs on the same electric motor and battery architecture already mass-produced for millions of ordinary EVs on the road today, production costs stay dramatically lower than custom aerospace hardware, which matters enormously because price is the single biggest wall standing between flying vehicles and regular consumers. A Saturday morning drive to an open field, one button, and a personal aircraft launching into open sky, that's not an upgraded road trip anymore. That's an entirely new category of Saturday. And the very next entry doesn't just simplify flying, it removes the pilot from the equation completely. Number 7, the Ahong EH2-16S, the aircraft with nobody flying it. Where Xpeng separated the car from the plane, Ahong went further and separated the human from the controls entirely. The EH2-16S is a fully autonomous passenger drone. You sit down, select a destination on a screen, and the aircraft flies there on its own with no stick, no wheel, no pedal anywhere inside the cabin. Here's why this actually matters beyond the novelty. In October 2023, China's Aviation Authority issued this aircraft a full type certificate, the highest safety classification any aircraft can receive, the same regulatory tier that governs commercial passenger airliners. Government inspectors tore the design apart, stress tested it under adverse conditions, and formally confirmed it safe to carry real human passengers, making the EH2-16S the first fully autonomous passenger-carrying aircraft in world history to clear that bar. Not a prototype, not a proof of concept, a certified aircraft with a government stamp on it. It runs 8 foldable arms carrying 16 independent rotors, seats 2 passengers, and stays connected to a ground control team throughout every flight, who can intervene if anything goes wrong. Though, in the overwhelming majority of flights, the onboard AI handles takeoff, cruise, and landing without a single human input. If the idea of trusting your life to a pilotless aircraft still feels uncomfortable, the next machine throws that entire philosophy out the window and replaces the computer with pure human muscle and 5 jet engines strapped to a body. Number 6, the gravity industry's jet suit, personal flight with 0 autopilot involved. This is the opposite instinct entirely. Not a machine flying you, but you flying the machine using nothing but your own limbs. British inventor Richard Browning built the jet suit around 5 miniature jet turbines, 2 mounted on each arm and 1 on the back, generating a combined output north of 1,000 horsepower, which is more raw power than a Bugatti Chiron produces from an engine the size of a small car, except here it's strapped directly to a human torso. Direction comes entirely from body mechanics. Lean forward, and you move forward, shift your weight left, and you bank left, and mastering it demands real physical training. This is not a toy you strap on and casually hover in. Top speed reaches 53 mph with a ceiling near 12,000 feet, and here's the honest limitation nobody should gloss over. Fuel burns fast enough that a full tank buys roughly 10 minutes of flight, which sounds restrictive until you remember what 10 minutes of vertical mobility means to a paramedic trying to reach an accident inside gridlocked traffic that would otherwise cost 20 minutes on foot. Military and emergency response teams are already running field trials, and every single minute logged in that suit generates flight data that shapes the next. Longer-legged version of the same idea, this is the Wright brothers' 12 seconds at Kitty Hawk, compressed into a jet-powered exoskeleton. From raw physical extremity, the next entry swings back towards something built for absolutely everyone. Number 5, the Jetson 1 being called the Tesla moment for personal aviation, and the comparison holds up under scrutiny. Where the jet suit demands training and nerve, the Jetson 1 is engineered specifically for people who've never flown anything in their life. The single-seat aircraft weighs just 190 pounds, lighter than most full-size motorcycles, runs on 8 independent electric motors, tops out around 63 mph, and in a growing number of jurisdictions requires no pilot's license whatsoever. The real engineering achievement is invisible. An onboard flight computer handles every axis of stabilization automatically, correcting pitch, roll, and yaws faster than any human reflex could manage. And if you release the joystick mid-flight, the aircraft simply holds its position in a stable hover and waits patiently for your next move, functioning less like an aircraft and more like a very forgiving flight instructor built into the machine itself. Early owners consistently describe their first flight as one of the most intense experiences of their lives, and pricing, while still steep today, is already sliding downward as production scales. The exact trajectory electric cars, smartphones, and personal computers all followed on their way from luxury novelty to everyday appliance. Right now, the Jetson 1 sits at the early adopter stage of that curve. Give it 5 years, and this list looks completely different. And while the Jetson 1 reshapes flight for individuals, the next machine reshaped what an entire industry believed electric aviation was even capable of. Number 4, the Autoflight Prosperity, the air taxi that just rewrote the electric distance record. This is where personal flying vehicles scale up into something built to move real numbers of people across real cities. The Prosperity is a large electric vertical takeoff aircraft engineered for multi-passenger routes between metro areas, and it recently set the world record for the longest flight ever completed by an electric aircraft in its class, covering 155 miles on one single charge, roughly the straight line distance from Washington, D.C. to New York City, flown without burning a drop of fuel. For passengers, the experience mirrors booking a rideshare. You book, you board, and the aircraft's AI handles the entire flight from liftoff to landing with zero manual control involved. What genuinely separates the Prosperity beyond the range record is its layered safety architecture, multiple independent fail-safe systems stacked on top of each other. If a critical component fails mid-flight, the onboard AI can deploy a full ballistic parachute in a fraction of a second, lowering the entire aircraft to the ground safely. And if a parachute isn't the appropriate response, the system can independently execute a complete emergency landing sequence with no human intervention required at all. That density of redundant protection is precisely the kind of engineering that eventually convinces ordinary commuters to trust an autonomous air taxi more than they currently trust their own daily commute. And statistically, once the data accumulates, they'll likely be right too. If that distance record impressed you, the next entry throws distance out entirely and chases pure speed instead, at 186 miles per hour through open sky, with no track and no walls. Number 3, the Airspeeder Mark III, built for the world's first competitive flying car racing series. Pilots aren't even physically present in these aircraft. They sit in remote command centers wearing VR headsets, seeing everything the aircraft's cameras see in real time, and race these machines through fully three-dimensional aerial courses at speeds up to 186 miles per hour. For comparison, Formula One cars hit similar speeds on flat asphalt tracks bounded by walls and barriers in exactly 2 dimensions, while these aircraft are navigating open airspace in 3, guided entirely through a headset and split-second reflexes. It looks like spectacle because it is spectacle, but the deeper function is identical to every major motorsport series in history. NASCAR's decades of racing produced breakthroughs in tire compounds and engine durability that eventually reached ordinary cars. Formula One pioneered carbon fiber construction and aerodynamic principles that trickle down into the vehicles regular people drive today. The Airspeeder series exists to do exactly that for aviation, pushing collision avoidance software, sensor fusion, lightweight composite materials, and battery management systems to their absolute breaking point under race conditions, so that every near miss and every mechanical failure generates engineering data that makes the next generation of civilian flying vehicles measurably safer. That obsession with extracting maximum performance from every gram of material connects directly to a parallel breakthrough happening down on the ground, one we're building toward for the second half of this video. Number 2, the pivotal helix, and the delivery drone network racing to meet it in the middle. The pivotal helix is an American-built ultralight aircraft with a fixed-wing airframe and 8 tilting rotors, weighing just 254 pounds, roughly the weight of a large adult male, which under U.S. federal ultralight regulations means it requires 0 pilot's license to fly. The manufacturer claims new pilots can learn to operate it safely in under an hour, a bold claim that holds up because the flight computer manages takeoff, landing, and in-flight stabilization automatically, leaving the human to focus purely on direction while the software handles everything else. What makes the Helix genuinely significant isn't the machine alone, it's the philosophy behind it. American aviation policy has always leaned toward individual freedom, minimal barriers, lightweight aircraft accessible to ordinary citizens, and the Helix fits that framework precisely. Across the Pacific, an entirely different strategy is scaling just as fast. Fleets of autonomous delivery drones already move hot food, medicine, and packages to automated pickup kiosks across multiple Chinese cities, with 0 human delivery drivers involved anywhere in the chain. That delivery network isn't just a convenience upgrade, it's a live training ground. Coordinating thousands of drones through crowded city airspace every single day generates exactly the traffic. Management software and safety data needed to eventually route hundreds of personal aircraft through those same skies without incident. 2 philosophies, individual freedom on one side and managed scale on the other, both converging on the identical destination, a sky as routinely traveled as the highway beneath it. And the machine at number 1 is the clearest glimpse yet of what that destination actually looks like. Number 1. The XTI TriFan 600, the aircraft built to make regional airports irrelevant. This isn't a weekend toy or a short urban hop, it's a full-size hybrid aircraft, engineered to replace short and medium-haul regional travel entirely, and its mechanical design has no real predecessor. It runs 3 large ducted fans, oversized enclosed propellers rather than exposed blades, 2 of them mounted inside the wings on rotating housings. At takeoff, those 2 wing fans point straight upward, lifting the aircraft vertically like a helicopter, and once it reaches altitude, they physically rotate forward, transitioning the aircraft into fast, efficient horizontal flight, exactly like a conventional airplane, while a 3rd fan in the tail manages directional control through the entire transition. That means the TriFan 600 can launch from a rooftop helipad, a corporate parking lot, or private backyard. No runway, no terminal, no airport infrastructure required anywhere in the process. Once airborne, it carries 6 passengers at a cruising speed of 380 mazimak thrusters, climbs to 30,000 feet, and covers a range of nearly 1,500 miles, roughly the distance from Chicago to Los Angeles, in a single hop. Translate that into daily life. A highway drive that currently eats 5 to 6 hours of gridlock and rest stops. Compresses into a 90-minute door-to-door flight. And that kind of compression doesn't just save time. It rewrites where people choose to live, where companies choose to build offices, and which small towns suddenly become viable places to headquarter a business simply because they're now 90 minutes from anywhere instead of 6 hours from everywhere. The TriFan 600 is the long game version of this entire story, not beating rush hour across town, but erasing regional distance as a limiting factor entirely. Now, before we go further, it's worth being honest about where all 8 of these machines actually stand today. Full type certification like the EH216S received is still rare and, so far, largely confined to Chinese airspace. Most other countries haven't cleared a path for autonomous passenger aircraft yet, and consumer-grade vehicles like the Jetson 1 and the pivotal Helix remain expensive, low-production, early adopter purchases, rather than anything approaching mainstream availability. This is the genuine leading edge of the category, not a fully mature market. But leading edges are exactly where industries get rewritten, and while these 8 machines were rewriting the sky, a completely different group of engineers was quietly rewriting what happens underneath every car still stuck on the ground. 106 miles on a single gallon of gasoline. In April 2026, at the Beijing Auto Show, a Chinese automaker called Geely walked onto stage and displayed a number that left engineers across 3 continents genuinely speechless for a moment. 106 miles per gallon. Not inside a laboratory under ideal conditions, but on an open public highway loop in Hainan province, in an ordinary mid-size family sedan, with official Guinness World Records adjudicators physically on site, verifying every single measurement in real time. Officially certified. Independently verified. Stamped into the record books. To understand why that number matters, you need one basic fact about combustion. When gasoline burns inside a standard engine, only a fraction of that chemical energy actually becomes forward motion. Engineers call that fraction thermal efficiency, and the rest simply escapes as wasted heat through the exhaust and engine block. A typical gasoline engine sitting in a normal driveway right now converts roughly 30 to 35% of its fuel into motion. Everything else is heat thrown away into the atmosphere. Toyota, the company that essentially invented the modern hybrid and spent 3 decades refining it, maxed their most advanced production engine out at 41% thermal efficiency. And for years, that number stood as the industry's undisputed ceiling. Geely's new engine, called the B15, hits 48.41%, independently certified. Here's the comparison that actually lands. Formula One engines, the most sophisticated internal combustion engines ever built, machines costing millions of dollars apiece and rebuilt after nearly every single race, operate around 50% thermal efficiency. Geely built an engine sitting within arm's reach of Formula One performance and put it inside a family sedan that costs under $10,000, paired with a 308 horsepower electric motor and an AI energy management system deciding in real time whether to draw from the engine, the battery, or both simultaneously. The combined result is that certified 106 miles per gallon on a public road in a car an ordinary family can walk into a dealership and buy today. For scale, when Toyota drove a Prius coast to coast from Los Angeles to New York in 2024, specifically to showcase peak hybrid efficiency, that widely celebrated demonstration averaged 92.9 miles per gallon. Geely's system beats that landmark run by more than 12% in a car costing a fraction of the price. And Geely's own executives have said publicly that this powertrain will outperform every hybrid Toyota, Honda, and Nissan have ever brought to market. And looking at the verified numbers, that's not marketing bravado, that's just arithmetic. But this is bigger than one engine and one record, because Geely didn't build this in isolation, and 106 miles per gallon isn't a fluke sitting alone at the top of a curve. It's the visible edge of an entire wave. BYD, the company that recently overtook Tesla to become the world's top-selling electric vehicle manufacturer by volume, just launched its 5th-generation hybrid system at 46.06% thermal efficiency, with its flagship model now traveling over a wowzer's 300 miles, combining a full tank and full battery charge, roughly the driving distance from Miami to Boston without a single fuel stop. Other major Chinese manufacturers, including Chang'an, Chery, GAC, and Great Wall, have all released comparably ultra-efficient powertrains within the last 18 months, with smaller brands now routinely hitting 45% thermal efficiency in standard family vehicles, a number that was pure laboratory theory just a few years ago and is rapidly becoming an industry baseline. Meanwhile, legacy engines built in Detroit by Ford, General Motors, and Stellantis are still largely operating in that same old 30 to 35% range, and that gap does not close on a short timeline. Redesigning an entire engine platform, retooling factories, and retraining engineering teams takes years, not quarters, which means the efficiency gap between Chinese hybrid powertrains and traditional Western combustion engines isn't just wide right now, it's actively widening. And here's the part that guarantees this technology doesn't stay contained inside Chinese borders. Geely doesn't only sell cars under its own name, it owns Volvo, it owns Polestar, it runs a major joint venture with Mercedes-Benz, and it actively licenses these powertrains outward to other manufacturers. That means these same ultra-efficient engines are already on a path into European and American vehicles within the next few product cycles, whether legacy Western brands develop competing technology in time or not. So here's the fast version. A truck that berths its own aircraft in an open field, a certified pilotless drone cleared to legally carry human passengers, a jet-powered exoskeleton that turns a human body into an aircraft, a 190-pound personal flyer designed to babysit total beginners through their first flight, an electric air taxi that just flew farther than any electric aircraft in history while carrying built-in parachute failsafes, a racing series piloted entirely through VR headsets at 186 miles per hour, an ultralight aircraft requiring no license at all, backed by a drone delivery network already training the software that will manage tomorrow's crowded skies, a hybrid aircraft capable of turning a 6-hour highway nightmare into a 90-minute door-to-door flight. And underneath all of it, on the ground, an engine that just certified at 106 miles per gallon, closing in on Formula One efficiency, inside a car costing less than $10,000. None of these are separate stories. They're the exact same story, told twice, once in the sky and once under the hood. The wall between advanced engineering and what an ordinary person can actually afford and use is collapsing in real time, the same way it collapsed when a phone stopped just making calls and quietly absorbed your camera, your map, and your wallet within a decade. Transportation is having that exact moment right now, and the companies leading it are not always the names you grew up trusting. If this gave you something genuinely new to think about, hit the like button and subscribe so you don't miss the next breakdown, and turn on notifications so you catch it the moment it goes live. Here's the question I want you to actually sit with between a flying vehicle that lifts off from your own driveway and an engine that carries you over 1,000 miles on a single tank. Which one changes your actual daily life more? Drop your answer in the comments below. I read every single one.